All right, here we are with another video. Um, we are still working on uh, dates and times library. This is something I'm definitely gonna have to go through again. I think the reason, so and I don't fully understand everything in this library, and I think it's mainly because they're just not using it enough. Transition this over here to where we left off. Date and time, which is the library, ctime library. This is the last bit of example code we wrote. W3 schools here. By the way, if you're not familiar with it, W3 schools, it's on the right here, and VS Code is on the left. This is one of the sources I'm using to learn how to write C++, but there is a lot to it. Not to mention just the basic parts, but then you got all the libraries, and those are there's lots to learn in those too. And that's just the standard libraries, not to mention all the other libraries that other people have created. And like I said, you can create your own libraries as well. Very useful when you need to create a library for it to do something and then add it to a project that you are working on. um, which when if a game is something you're trying to build, then you might build a game engine and then turn that into kind of a library itself. That way you can use it for other projects besides just one project. But libraries is something I don't fully understand is because I don't go through it enough. So what I mean by that is the beginning of this tutorial, we pretty much discuss all these basic parts: data types, user input, variables, math, strings, booleans, loops, statements, etc. But we use all that when learning or discovering or even writing any kind of code. We use all that on a daily basis all the time if you're writing code all the time. With the libraries, you don't use them all the time. And when it comes to learning anything or memorizing anything, it's something you got to do repetitively over and over and over. That pertains to just about anything. Um, we drive on a daily basis, so we all form good and bad habits of driving, but it just starts becoming natural to us jump in the car once we get to do it so often. Uh, it could be riding a bike or rollerblading or playing any kind of sports. Once you do it enough times, you get all the details down into what makes it better and try to form those better habits and stuff to make it better, and then try to find other things that can improve upon it. And what makes this difficult for me to understand this library, besides the fact that I just don't use it enough, is not understanding what these types are. So I don't think that this material has really told me what this is. Um, if you remember correctly, when we declare a variable, we have or declare something. It doesn't matter what it is, but the variable is normally a descriptive word that describes what the value of that variable is. If it's people, you might use number of people. If it's a date, you might use date of whatever, birth date or whatever. If it's a game, you might use the character's name and the stat for it, etc., etc. I don't know what strftf time is. It's obviously a uh, shortened word, probably without a lot of the vowels or whatnot and stuff, but I have no idea what it is. Straight front time or straightforward time. Yeah, I couldn't tell you without the full word being there. And since the material is not really telling me what that word actually is meant to be, and they may not know. The people that developed this website may not know. But all these symbols right here, or characters, or whatever you want to call them, abbreviations and stuff, at least that's in here with a description of it. So like the uh, percentage A right there. There's at least a description of it right here, short representation of the weekday. The percentage P right here. I mean, that one was kind of obvious, AM or PM. Depends on if you use, you couldn't use A apparently, but um, I don't know how it would determine if it's AM or PM exactly. It just says AM or PM. So I don't know if there's another one for AM or if it's determined off of what you have previous to that. Let me run this code one more time here real quick. I got it highlighted. Okay, so down here in the terminal we have it's showing AM. It's actually showing my relative time currently. So maybe that is how it's determining that based off of what's in this location right here. And it's using percentage P to determine whether it is AM or PM or not. So it's not so much that this represents AM or PM. It's just giving it the ability to add that in there with one way of telling time over another way of telling time. Because if you had this time in there without the AM or PM, you wouldn't know if it was AM or PM. Anyways, we left off in our last video with measuring time here. Again, in order to actually understand this fully, we're going to have to go through it multiple times. But I'm not sure if this material actually has all the information we need to fully understand this library completely. So uh, maybe finding other sources for the library or whatnot. But I think, like I said, I think there's like 17 standard libraries. Standard libraries is something you would use commonly in your code, built by somebody else as a program itself. Um, so, anyways, let's get started on this and get through this section. I think this is the last bit before we're done with this section. We'll definitely have to come back to this again to get it memorized. I said I do remember some of this now that I've gone through this right here, but I don't have it solid. So, anyway, measuring time. The two different functions that can be used to measure differences in time. The diff time, now that one makes perfect sense. Difference time function measures the number of seconds that pass between two different time stamps. This is useful when measuring time differences between dates. I noticed that it says measures the number of seconds. Why would you use seconds? And that kind of makes sense in a logical standpoint. If you were measuring hours and stuff, then you might not get the difference in minutes or seconds because it wouldn't have minutes and seconds. But if you measure seconds and stuff, the computer can take that figure and break down the minutes, the hours, the days all into seconds, which would be, yes, a pretty good sized number depending on how many days and minutes and hours you have, or even years you have between two different dates. But still, it can give you a difference down to the second that away. I don't know if you can change that from seconds to minutes or hours or whatnot, but anyways, we have an example here measuring the time difference between two timestamps. So let's get this example put into our code. We're going to go ahead and clear out all this. Let's see. So the first thing we have is time now declared time next year declared, and then struct tm date time declared now is going to be time null declared date time is going to be local time. I'm still trying to get it memorized and stuff as to what the asterisk key indicates in that current position. Most likely a pointer to a reference of now, which is the variable up here. I don't have all that right in there right. There we go. That's declared date time dot tm year underscore year. That's what I was missing. Didn't even put it in there right. Is date time dot tm underscore year plus 1 declared date time dot tm underscore. I'm going to make this simpler on myself here in just a minute instead of continuously writing this out, because we got 1, 2, 3, 4, 5 more to do. So let's go ahead and take that, copy it. There, 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 and make the adjustments we need to it. So the first one is correct. Is 0 declared. This next one is not correct. D is 1 declared. The next one again is not correct. This is hours set to 0 declared. The next one is minutes. All these are set to 0 declared. This one seconds is again 0 declared. And the last one is standard daylight savings time. Is DST. And this is going to be set to -1 declared. Move this over here. And we got next year is MK time. And again, I'll try to go through and decipher this code, or basically try to understand what it's doing here at the end of this, but I probably won't be able to very well. Is diff time next year now declared standard output diff seconds until next year and save. Now, so let's see, we have a now time and then a next year time. So basically 1 year from now is our two variables that we're declaring for time. We got a structure here with a type tm, which is in the ctime library, and a variable name date time. For now, we are declaring the time null, which is probably the current time, but like I said, I don't fully understand the word null yet. I haven't researched that or studied that one enough to have it memorized. And we got several different date times here, obviously, for telling local time, which is set with now as well. And then we got our set year. So I believe this one is kind of incrementing by 1. That's what it looks like. It would be the x equals x plus 1, which is the same thing as date time plus plus, if I'm not mistaken, or date time plus is 1. 3 different ways of writing this. I believe that's the way that is. We can try it out later just to, 'cause I have it in memory, but the only way to get it concrete in there is to try it the other different ways. Because this code, I believe, can be written out like this as well. Uh, date time dot tm underscore year plus plus. I believe that is one way. I believe the other way is date time tm underscore year plus is 1. So I believe that that's all this line of code is doing, is incrementing the current year plus 1 year plus 1. So currently it's 2026, so we're incrementing it by 1 to indicate that we just want a difference between current year and the following year. Um, now the month, we have it set to 0, so um, if it was determining our current time, it would be a different story, but I don't think it is. This shows it's trying to get the now time, I believe. Setting now to the current time, and then giving date time now's reference location. Reference data in that reference location. Sorry. Setting the month to January, well, or 0. I can't remember what that's doing right there. Then the day of the month, which is first. So if I'm not mistaken, this is supposed to be January 1st, but it may not actually put all that stuff in there. This may actually correct all that, the MK time. And then obviously minutes, zeros, or minutes, hours, yeah, hours, minutes, and seconds all set to 0, which again, this may correct all that. We just have a set value in there currently. If we wanted a specific value in those spots and stuff, then we would set a specific value. I believe that this right here is going to end up correcting all that for the current time and then a year from now, and how many seconds there is between in 1 year, which is going to be quite a bit. And daylight savings time is unknown, but again, this is going to be correcting that. Next year, though, is going to be set to the correction of that. So we got next year and now set for the difference time. So it should be, if I'm not mistaken, in the ctime library, take an expression, and it would probably be next year minus this year and give us our seconds between the 2 years. So yeah, it says the difference seconds until next year. So we've already saved this, I believe. I thought we did anyways. Let's go ahead and run this. And yes, it gives us a, what is that, 17 million seconds until next year. So there's a little over 17 million seconds in a 1 year span, which I knew it would be quite a bit. Yeah. So moving on from there, we are starting to understand this. Like I said, I think this is the second time I've gone through this, and some of this is coming back to me. It's probably been about a month or two and stuff since I've seen this stuff for the ctime library. And there's quite a few libraries out there I still haven't seen yet. I've seen, in fact, I'll bring that up now. Um, right here, here. Uh, so the different libraries. Diagnostic library, I have not seen that one yet. In fact, most of these I haven't seen it. The general utilities one, I got started in that one. But yeah, and it's not the fact that I just have been slow about it. It's just I've only started learning this C++ just a few months ago, 3 months ago at best, maybe 4. I don't know, but just a few months ago. Um, and I'm still working on trying to get the basics down. And we're jumping into libraries already, and the only one I've ever seen is this one here. Besides this one here, I may have seen some of these other ones, um, but I don't remember them because I just haven't been using them enough. I've been trying to get the basic stuff down pat first. 'Cause like I said, I think null is part of the basic. It gets used quite a bit. The pointer stuff, I know it gets used quite a bit. The reference and dereferencing stuff, yes, I know it gets used quite a bit. Um, the new, the delete, creating a file, all that sort of stuff, it gets used quite a bit, and I just don't have it yet concrete in my mind. So moving on from there. Looks like we got one more example down here. The clock function is useful for measuring short intervals of time while the program is running. It is more precise than the difference time or difference function. Each call to the clock function returns a special kind of timestamp measured in clocks. I don't think it's referring to the same thing that we instantly think of when we think of a clock. Something that basically tells time, but it tells the time, not the date in time. So each call to the clock function returns a special kind of timestamp measured in clocks, a unit of time that depends on how the library was implemented. A unit of time that depends on how the library was implemented, which was a data type, clock type. To measure a time difference, store a timestamp at two different moments in time and then subtract them. The time difference is measured in clocks, but you can convert it into seconds by dividing um, it by the clock per second constant. I assume that what it's getting at is if you want to determine how long it takes for your program to run. I mean, yes, you can clock it yourself, but if you want it to clock it for you, my programs and stuff probably just less than a second, maybe a second. Um, Especially since it's so short. But if you have a really long program and you want to determine how long it's taking that program to actually run, I think you can use this method right here to determine that. We'll find out though. There goes the yawning again. I don't think I'm breathing enough when I'm doing these videos. I think that's what it is. My body is lacking some oxygen, so it's making me yawn when I'm doing these videos because I say so much in one breath. And I'll inhale. Anyways, let's get this example written in here. Let's go and clear out this code right here and see what this does here. So we got clock underscore t before set to clock uh, with a parameter. I'm going to call it a parameter, parentheses parameter. I know functions have parameters, but other things have statements. So maybe just, I'll try to remember to call it parentheses or what it is for each different thing it's being used for. Integer k is going to be set to 0. For parentheses, this will be 3 statements because it's going to be a for loop. And saying that out loud and stuff, it kind of makes me have to try to remember what it actually is I'm putting in here. Looks like we're going to do 100k. I incremented 2 and then the for loop code, which is k plus is I. I did forget to do that in the last example and stuff, change out that one code multiple times and stuff to see it would do the same thing to ensure that it was going to do that. But we're kind of past that already, so clock underscore t duration is clock parentheses minus before, and then a standard output duration float duration divided by clock, and this is all capital letters, clock per second. Yeah, it's all the way down there at the end. Seconds, and we don't need caps anymore. And then in that. Okay, let's see what we have here. So the first thing we're doing is we are declaring a type, which is clock type with the variable before, giving it a value of clock with parentheses. I'm not sure exactly. This is a clock function. Is that what that is? Clock function? Yes, clock function. Okay. We are declaring a type integer, giving it the variable name k, setting it to 0, putting this into a loop, a for loop, with the first statement being I, type I variable set to 0, and as long as I is less than 100k, increment I by 1. And we're going to start off with k. Well, it looks like k is going to be incremented as well. So I is going to be incremented and k is going to be incremented based on I. You know something I don't see? Why don't I see it? Ah, I think I see what's going on here. So it's counting literally the time it takes for an incrementation to go up to 100,000. K being the representation of that. So it will end up printing up, let's see here. Duration, which is going to have a type clock again, is going to be set to clock minus before. So this loop right here is literally just running over and over and over. And the only thing we are outputting is how long it takes, maybe in seconds. Yeah, in seconds. How long it takes in seconds for this program to actually increment I up to 100K, as well as and giving it something to add to. So this is going to run kind of a long, extensive program. Depending on your processor, it may be kind of hard on your processor because it's going to run pretty much as fast as it possibly can. But it's going to give you a time of before and during, or at the end, and then it's going to give you the duration of how long it took for this program to run this loop. So we got the before, the current, which is going to be set to now, minus before, and tell you pretty much how long it takes to run this program. So let's go ahead and save it and see how long it takes my PC to run this. Obviously, every system, every PC is going to be different on this. Depends on what you have going on in the background, which programs you have going on. Also depends on your hardware. Will determine the time it takes, and it may not even be the same every time. So let's see how long it takes the first time. It took for it to increment that no time at all. Not even 1 second. Not even a tenth of a second. Not a hundredth of a second. more like a thousandth of 1,000th of a second for this to increment, continuously running this loop and stuff until it incremented up to 100K. So run it again. This time it took one less than, it didn't take any time at all. I'm going to change this to double so we can get a more precise value. Float will only go to this point right here. I'm going to change this to double so we can get more. Now, before when I did this sort of thing right here, I could not have done this. I would not have known to change that float to a double. Let's see if we get a better result. Much smaller result. Okay, still 100 and 1,000ths of a second. Again, it didn't take any time at all. So, yeah, if you have a decent computer, probably one built this year, then this program, it doesn't matter what the hardware is, as long as it's not something cheap. This right here shouldn't take you a second to do. Let's increment this by one more. Let's actually see if we can't get a value in there. Okay, 200ths of a second. No, 2,000ths of a second. Let's increment it one more. Okay, now we're actually getting some time. A little bit of time. Yeah, it looks like it takes 13,000ths of a second, if I'm reading that correctly. Let's see it again. Yep, 13 thousandths every single time. Let's add another zero in there. Why not, right? Now we're getting into a tenth of a second. It's taking a little bit of time to get that done now. Let's go ahead and throw another zero in there. Why not? Now that took a second to do. That one actually took a second for that to run that loop. And I think we'll stop there. So the first time the 100K and stuff, I mean, older computers, really old, like this laptop and stuff, yeah, it might take a second for that to run 100K. A newer computer, how many zeros do we have in here? Let's see, 3, 6. So that's 1 billion. It's taken just a hair over 1 second to increment I up to 1 billion. Just over 1 second. If you notice, there is kind of a slim pattern here and stuff. I mean, you couldn't see it at first. Let me bring this up here a little bit. So there's a slim pattern here. The first time, I mean, actually, yeah, the first few times it would barely register anything at all. It wasn't until we started incrementing it, and then we got 2 out of it, and then it went to 1.3. But I start seeing a pattern here, so I checked it multiple times, 1.3, 1.3, 1.3, add another 0 to it, 1.2, but since it's not giving a more precise value to that, and I'm not sure how to get a more precise value out of that, it's probably rounding it up. So it's probably 1.22, but it's rounding it up to 1.3, because now we got 1.22, so I'm guessing if it was more precise, it would be 1.2, 0.121 something, and then it's rounding it up. In the next example right here, we got actually 1 second, 1.2 seconds, and you can see it's a little bit more precise, but I had to put 1 billion incrementations in there in order to actually get at least 1 second out of it. So yeah, if you want to write this program down and stuff and see how many zeros you can get in there before you get it to last 1 second trying to run the program. And this is not a lot of code right here, but that is a huge loop, 1 billion. I'm sure I can add another zero in there and stuff, and it may not go up to 10 seconds, but still it's quite a bit. Anyways, you can play around with that if you want to. You can create another loop inside to where it's got a loop inside of a loop. change it back to 100K and make the inside loop go 100K, to where you have two different loops doing 100K each, and see how long it takes for your PC to run that program. Like I said, this is going to be based on what are the programs you have currently running. It's going to be based on uh, what's going on in the background that you may not be aware of. It's going to be based on the hardware you have, sort of thing. So, yeah, go ahead and give that a shot. Write that code in there. Add multiple loops inside if you want to, um, because there's actually a little bit more going on. Because once it gets to this line right here, it prints it up, but so you only see the time difference between just for the loop, because it's measuring from here to here. It's not measuring how long it also takes to actually add that to the output. But anyways, moving on. Note, make sure to cast the value of float or double type before dividing. Otherwise, it may result in an integer division, which would cause the decimal part to drop off. So basically, it's, yeah, float or double. I use double right there because I wanted to see if it would get more precise, and it doesn't look like it's going to get more precise than what it is right now. But if you don't have that, then you may not see anything. It may keep showing 0, 0, 0 every time because it's doing it so quickly. And then you may have to continuously incrementing it stuff just to get a value out of it. So yeah, float holds, I think, 5, 6. I'm trying to get that memorized too. 5 or 6 decimals or digits to the right of the decimal point. I think it may no maybe up to 6 to 9, somewhere in there. I think double goes like 15. But yeah, it's not getting that precise either way. It's only doing a couple after, so float's fine. I'm not sure how to get it to give us a more precise number, but anyways, moving on. So for W3 schools, the complete reference guide for ctime, which is down here. I think I've seen it the other day. Yes, right here. That's the complete reference guide, which we haven't got to yet. Um, which when we get into these things and stuff, it should be pretty quick unless the material is really long. But we'll get to that when we get to that. So for now, that's pretty much the end of this library right here that the W3 Schools has. I'm pretty sure there's probably a lot more information on this than what they're showing, but um, we'll get into more details on it and try to go back to it and back to it and back to it to get it more solid in memory. For now, we're going to move on to the next. And then our next video, we'll start working with errors, debugging. Pretty much this entire next 4 sections and stuff we're going to be doing is going to be dealing with errors, which you see me do that all the time. Whether I am forgetting to put this in there, or forgetting this right here, or misspelling stuff. That's my biggest thing, is misspelling stuff, trying to get my fingers to work properly, trying not to forget some things, which I do it all the time. Get other errors and stuff too that sometimes happen, but yeah, that'll be on our next video, starting up our next video. As usual, if you like the video, hit the like button. If you have any comments, questions, put them in the comments. If there's something I said again that is not correct that you know of, you would like to correct something I've said, that's fine. Um, again, I'm not here teaching, I'm here sharing just my journey. So uh, if you have any other code and stuff that you'd like to share and stuff and that does something unique and stuff, uh, I won't really download the code, but I may copy the code into VS Code if you want me to try it out, and then I will try to decipher it and see what it's doing. Granted, I am still a beginner, so I may not fully understand the code, and if I don't trust the code and what it's going to do, I may not run it. As you've seen in my previous videos, when it came to the new and delete keyword, it's something I didn't run. But when it came to creating a file, I knew what it was doing, so I wasn't too concerned about it. But that'll be it for this video. I'll catch you next time.